Hi students, good morning. Today we are discussing about small concept in the part of fifth year group elements. Now that is allotropic forms of phosphorus. Okay, now that is the allotropic forms of phosphorus. Now here, so that concept name is allotropic forms of phosphorus or phosphorus allotropic forms. Okay, so this one is the phosphorus allotropic forms. Okay, now now we are going to discuss about these things. Now in organic chemistry, we know some elements they are obtained or they are found in that various allotropic forms. So especially very the most important allotropic form of carbon in the fourth year group elements. It is existing in that different allotropic forms. Okay. Now the carbon is existing as diamond, graphite, Buckminster Fullerene, coal tar, light. Okay, lamp black like that. So these are the different type of allotropic forms. So here also same thing. Now that is the allotropic forms of phosphorus. Now the phosphorus which is found in many allotropic forms. Okay, the phosphorus which is found. Okay, the phosphorus which is found in many allotropic forms. So this one is the many allotropic forms. The phosphorus which is found in many allotropic forms. So in this one, now we have the different type of allotropic forms of phosphorus. So first one is the white phosphorus, and second one is red phosphorus, and next one is the black phosphorus. Okay, so we want to see that white phosphorus. That means one of the most important allotropic form of white phosphorus, and the second one is the allotropic form of red phosphorus, and the third one is the allotropic form of black phosphorus. Okay, but here now we want to talk about white phosphorus. Is it clear now? So this is the white phosphorus. Actually, now the white phosphorus which is existing or which is present as waxy solid. Okay, now that is the waxy solid. Is it clear now? It is the waxy. Now that one is white. Okay, waxy solid. Okay, white waxy solid. Okay, now the white phosphorus which is existing in that white waxy solid form. And actually the white phosphorus, that means it is soluble in that it is okay, actually what happens here, it is insoluble in water but soluble in that carbon disulfide. Okay, now here it is insoluble. Okay, it is insoluble in water. It is insoluble in water, but what happens here, but it should be soluble in that okay, it is the soluble in that carbon disulfide compound. Is it right now? Carbon disulfide. So actually, this is the organic compound, but the water molecule means this is the inorganic compound. Okay, now carbon disulfide. So the first property of this one is the now the white phosphorus is a waxy. Okay, white waxy solid. And the second property of this one is the it is insoluble in water but soluble in that okay. What about that one here? Carbon disulfide. Okay, now carbon disulfide. So actually and it glows. Okay, that means it is glowing. Okay, that means the property it is glowing. Okay, now it is glowing. That property is called as chemiluminescence. Okay, now this property is called as chemiluminescence. And actually here the phosphorus which is have okay, now, which is obtained in that polymeric units. That means okay, now these are the polymeric units. So first one is that of now here I am erasing these things. Now next one is the polymeric. Actually you should take that this one is the white phosphorus. Okay, now it is actually white phosphorus. The structure of white phosphorus is like this one. It is existing in discrete units. Okay, discrete units like the structure. Okay, discrete units like, okay. So actually this is the bond which is connected with that phosphorus atom. Okay, now here it has the lone pair of electrons, and here also lone pair of electrons, and here also lone pair of electrons, and here also lone pair of electrons. And now these molecules suffer with angle strain. Okay, these molecules suffer with angle strain. So its bond angle is 60 degrees bond angle. Okay, now this one is the 60 degrees bond angle. Is it clear now? 60 degrees bond angle. But and one more thing is the, that means it is the less okay, now, stable in nature. White phosphorus is less stable. Less stable means that is nothing but more reactive in nature. Okay, now more reactive in nature. Okay, now what is the reason why it is the more reactive? Okay, why it is that? That means less stable means more reactive. Now due to the presence of when it is suffering with that when it suffer with that angle strain. Okay, and now it suffer with that angle strain. Due to the suffering of the angle strain, it is really very less stable. That's why that is nothing but more reactive in nature. Okay, more reactive in nature. So actually now the phosphorus element are white phosphorus. Okay, white phosphorus. So this is the white phosphorus, which is reacted with or which is reacted with boiling NaOH solution. Okay, which react with that 3 moles of NaOH and 3 moles of water gives rise to, okay, now it gives phosphine compound, and next the 3 moles of NaH2PO2 compound. Okay, sodium hypophosphite. The compound name is the sodium hypophosphite. Okay, is it clear now? Sodium hypophosphite. And again it is react with, that means it is ready to react with oxygen. Okay, it is ready to react with that oxygen. So actually p4 molecules, that means this the, okay, white phosphorus which is combining with kind of 5 moles of oxygen gives rise to, okay, and now this is the p4O10 molecule. It is the white fuming, okay, now white fuming. Okay, this one is the white fumes or white fuming gases are like that. Okay, now white fumes. So this is the white fuming material. Okay, this is the phenomenon. And these molecules are that discrete units. Okay, discrete units, that means discrete units means separate molecules. Okay, separate molecules. Now this is the one separate molecule. Actually this is the one separate molecule. So that's why it is the discrete units of p4 molecules. Okay, discrete units of p4 molecules. Is it clear now? So this is the phenomenon. So actually here okay, now these molecules, that is the p4 molecules which are, okay, the p4 molecules now what happens here? Now here the p4 molecules which are bound by van der Waals force of attraction. Okay, now these are bound by, okay, van der Waals force of van der Waals force of attraction. Okay, now these are bound by van der Waals force of attraction. Okay, now so this is the complete information about that white phosphorus actually. Okay, so up to here what we learned here, so actually now the phosphorus which is found in different allotropic forms. Okay, those are white phosphorus, red phosphorus, black phosphorus, like that. Okay, so these are the different allotropic forms. Okay, different allotropic forms. Actually white phosphorus is the white white waxy solid type of compound. Okay, white waxy solid type of compound. And the second property of white phosphorus is the white phosphorus which is soluble, okay, which is insoluble in water, but it should be soluble in the top of carbon disulfide. So here water is the ionic compound, but the p4 molecule is not a ionic compound. Is it right now? P4 molecule is not a ionic compound. So that's why the p4 molecule is ready to soluble in the top. Now that means organic compound, its name is carbon disulfide compound. Okay, na carbon disulfide compound. It's clear. And the next one is the now the p4 molecule, which is the monomeric unit. Okay, which is the monomeric units. Okay, monomeric units means like this one. So actually here what happens, so this is the one phosphorus atom, and here also one phosphorus atom, and here also one phosphorus. Okay, now one phosphorus like this. Okay, so these are the monomeric unit of phosphorus. Okay, and now it is suffering with that angle strain, or with bond angle. Okay, angle strain. So what is the bond angle in case of each and every phosphorus here? 60 degrees bond angle. Okay, na 60 degrees bond angle. Okay. So actually here once again the phosphorus molecule which is treated with, which is reacted with. Okay. What about that here? Alkali, or that means sodium hydroxide compound. Once again here I am repeating the equation. P4 molecules 3 moles of NaOH with water also. Okay, water. So then what happens in, it can produce it can use that phosphine compound, pH3 compound. And next one is the 3 moles of NaH2PO2 type of compound. Okay, sodium hydrogen phosphide or sodium hypophosphites are formed. Okay, so these are the forming compound. Okay, and again it is ready to react with okay, that means 5 moles of water oxygen molecule gives rise to, now this one is the p4, and next one the O10. So this is the white fumes. Okay, now white fumes are formed in case of this one. Okay, now and now this is known as discrete molecules. Okay, now people, that means white phosphorus is that of discrete molecules. Okay, now so these are the things. So actually it is the poisonous also. Okay, now p4 is the poisonous. Okay, now poisonous compound, poisonous form. Okay, that one is the which is obtained in the form of a poisonous. Is it clear now? Poisonous. And next one is the, we want to talk about that next allotropic forms. And now that is red phosphorus actually. Okay, now that one is the red phosphorus. Okay, now red phosphorus. So here actually how do you get the red phosphorus? Okay, now from where we have to prepare that red phosphorus? Actually red phosphorus is prepared. Okay, now so this one is the red phosphorus is obtained from that white phosphorus. Okay, now this one is the p4 molecule. Actually red phosphorus is obtained from that p4 molecules or white phosphorus at 573 kelvin temperature, which is heating on that conditions at it apply that inert atmosphere pressure. Okay, inert atmosphere. So that means it maintain that INERT, inert atmosphere. Okay, na inert atmosphere for several days. Okay, now for several days, then you have to got it red phosphorus compound. Okay, now red phosphorus is obtained. So it is the gray in color. Okay, now gray luster. Okay, now gray luster. So that means the shining of this one is the gray luster. And you have to take that and next one is the, this is the red color phosphorus. This is one of the allotropic form. And next one you have to take the same type of compound. Okay, now red phosphorus. So red phosphorus is heated on heating process. Now you have to get it so that is the black phosphorus is prepared. Okay, now black phosphorus is obtained. Okay, black phosphorus is obtained by heating of red phosphorus. And now the red phosphorus is heated at okay, now high pressure. We have to apply that at high pressure. Okay, now the red phosphorus is so this one is the red phosphorus is non-poisonous. Okay, no, non-poisonous. Okay, no, non-poisonous. And the red phosphorus is what about this one here? Which is insoluble in the top water molecule as well as the top carbon disulfide. Okay, no, which is the red phosphorus is which is insoluble. Okay, which is insoluble in water. Okay, as well as carbon disulfide. Okay, now the red phosphorus which is insoluble in water. Okay, now which is insoluble in water as well as red that means as well as carbon disulfide. Is it clear now? Carbon disulfide. So actually This is the phenomenon. And here if you compare the reactivity of red phosphorus, okay now reactivity of red phosphorus, okay. So this one is reactivity of red phosphorus. The reactivity of red phosphorus is less than that of the okay now what about the that one here, reactivity of white phosphorus, okay now reactivity of white phosphorus. So that means what happens here, what is the reason here? Now simple word, okay. Now that means white phosphorus reactivity is greater than the top reactivity of red phosphorus. So that's the phenomenon, okay. But here these phosphorus are discrete units, okay. Now discrete P4 molecules, okay. Now these phosphorus are the discrete, that means separate P4 molecules, which are okay, which are bound by that okay, which are bound by covalent bond formation, okay na covalent bond formation, okay na covalent bond formation. So how they are existing in that covalent manner? So in case of white phosphorus, so just now we observed that so in case of white phosphorus, monomeric units are existing, okay na. And now this is the white phosphorus monomeric units, okay na. These are the white phosphorus monomeric units, okay, like this one. So here, what is the hybridization here? 1, 2, 3, 4. That means this one is the sp3 hybridization and sp3 hybridization, sp3 hybridization, and here also sp3 hybridization. Okay, each and every phosphorus having the one lone pair of electrons and three sigma bond. Okay, but if we want to write about that, this one is the van der Waals force of attraction, okay now white phosphorus, okay now undergoes to the van der Waals bonding. That means these molecules are held by van der Waals force of attraction. But if we are talking about that if we are okay discussing about that um, what about that one here, red phosphorus. So here the red phosphorus is that now that means polymeric structure, actually that is the polymeric structure. Now how these are polymerized with each other, okay. So this one is the phosphorus, and here phosphorus, okay, phosphorus, and here also phosphorus, okay. So but here one, two, okay, two internal bonds are there, but here only one internal bond is there, okay. But here this is the one unit, and it is also combining with the top another phosphorus units, okay, like this one, and again which is combining with the top another phosphorus units like this, okay. So these are the what about this one here? Polymeric units, okay, polymeric units, okay. These are the polymeric units. And next one is the black phosphorus, okay. Now here we want to talk about that one, black phosphorus. Now here the black phosphorus are also two types, okay. Now here this one is the black phosphorus which is having two types, okay. One is the alpha black phosphorus, and the second one is the beta black phosphorus, okay. One is the first one is the, now that means black phosphorus has two allotropic forms. It has two allotropic forms. One is the alpha black phosphorus, and the second one is the beta black phosphorus, okay. Now beta black phosphorus. Now here alpha black phosphorus which is obtained by the heating of, okay, by the heating of red phosphorus, okay. So this one is the alpha black phosphorus. Is it clear now? Alpha black phosphorus. So in case of alpha black phosphorus, now alpha black, okay now phosphorus which is obtained, alpha black phosphorus is obtained by heating of red phosphorus, okay now heating of red phosphorus in shield tube, okay now shield tube, okay, at at 803 Kelvin temperature, okay. We have to maintain that conditions. Red phosphorus is heated at 803 Kelvin temperature, and now this phosphorus is heated in steel tube, that means closed vessel, okay. And now from this, okay, in this on that heating we got it, that means we have to produce, okay, we have to prepare that alpha black phosphorus. Is it clear now? Alpha black phosphorus. So this is the phenomenon. And next one is the what about the second type here? So that is the beta black phosphorus. So the beta black phosphorus is directly, okay, and now this the beta black phosphorus is also obtained from that okay, at 4 473 Kelvin temperature, okay, 473 Kelvin temperature at a high pressure. So that means by that one is the white phosphorus. Okay, now when we have to heat that white phosphorus at 473 Kelvin temperature and high pressure, we have to get it. That means we have to prepare that okay, black phosphorus. Okay, now black phosphorus. So here these are not ready. That means these compounds or these structures can can be sublimed. Okay, now these compounds can be sublimed. Okay, now sublimed with air. Okay, and it has a opaque mass. Okay, now opaque. Okay, now these are the opaque mass. Okay, that means opaque mass, and it has monoclinic structure. Okay, now monoclinic. And next one is the it shows that a rhombohedral. Okay, na rhombohedral structures. Okay, so this is about allotropic form of phosphorus. Is it clear now? This is the about allotropic forms of phosphorus. It's clear.